For today's lesson, our topic is linear relationships, more practice with linear data tables. Our essential question is, how do we identify the slope and the y-intercept for a linear relationship from a data table? Please take a moment, pausing the video if you need to copy the topic and essential question into your header, along with today's date, sub your question column and your note column, and resume the video when you're ready to begin. So this information was covered in our last video about introducing data tables and linear relationships, but I just like the reminder here that linear relationships are a pattern between two variables that change at a constant rate. That constant rate, that change, meaning that they add the same amount every time or subtract the same amount every time, that is what we refer to as the slope. And the two variables are x and y in this generic case, but you can use any two variables. And we use three different representations for linear relationships: graphs, equations, and tables. And so our goal today is to be able to look at tables and write a slope-intercept form equation based on the data given to us in the table. So with that, let's go ahead and jump into our first example. So I personally am a fan of the Inheritance Cycle series. It's a sci-fi series by the author Christopher Paolini. It's about dragons, and the last book is called Inheritance, and it's 850 pages long. So this is an example of looking at a linear relationship of the pages left to read in the book based on how fast someone reads. So I looked it up, and the average person reads 25 pages per hour. And so what I'm setting up here is a data table where x represents the number of hours. So we have 0, 1, 2, 3, 4. This could of course keep going, and you can look here. I wouldn't have finished the book if I read 25 pages per hour. For 4 hours. One way to keep a data table like this, the purpose might be, is to figure out how many hours would it take me to finish the book. In this instance, x is going to represent the number of hours I spend reading, whereas y is going to be the number of pages left. So before I've even started reading, there's 850 pages in the book that I need to read to be able to complete it. We're going to need to identify the slope from the table, the y-intercept, and put that into an equation. One thing that can also be helpful, because we've been studying a lot about lines on graphs, is just to set up a quick sketch of what this might be. It's going to start somewhere up here, if this is about 850, and it's just going to steadily decrease, right? And so every hour I'm reading at a pretty constant rate, assuming that I do. And I don't know exactly how many hours, but we could figure out, well, how many hours would it take me if I'm reading at this constant rate. So what we need to do is identify what that constant rate is, but we can see that it's going to have this negative rate. As I read, I'm going to have less and less pages to finish until finally out here at however many hours it takes me, there's 0 pages left and I've completed the book. Alright, so maybe by now you've figured it out. So we want to find that change in y and that change in x, and so if you haven't done so already, we want to label how much we see y changing by for every hour that we see x changing by over here on the left. So let's go ahead and add in those labels. So if we were going to label the changes that we see in this data table to help us identify the slope, we can see that from 850, our starting number of pages, it dropped, it subtracted 25 and became 825 pages left, then subtracted 25 again to become 800, and again and again. So y is changing at a constant rate. It's decreasing 25 pages. Over here for change in x, the hours are increasing. So I start at 0 hours read, and then I add an hour, and I add another hour for 2 hours, and so the hours keep increasing by 1 hour at a time. So to put this in context, our slope, or the rate of change of how fast we are reading through this book, or I'm reading through this book, is that my change in y is negative 25 over 1 which is equivalent to just saying negative 25. So we're reading through this book at 25 pages per hour, or the number of pages left in the book is decreasing 25 pages for every hour that we read. And that is our slope right here. And so the y-intercept is, well, where did it start, right? So when x is 0, what is y? So this is where I look right here. When x is 0, what is the y value, right? Because on our graph right here, when x is 0, where's it going to start at? Well, for this, it starts out at 850 pages. So my y-intercept, or my b value, is 850. So the equation that I can write, now we just need to write out this equation. So my slope, or the rate of change, was that it's decreasing 25 pages for every hour. And I started at 850 pages. So if I wanted to, I could use this equation to figure out, well, how many hours is it going to take me to finish reading this book? And perhaps you're ready to figure that out, and you can put that answer right here, and I'd love to check your work when I check your notes. Let's go ahead and take another example and see if this time you can analyze the data table, sketch out a graph, and come up with the equation. Alright, so for our second example, we're going to be looking at the candle height as it burns over time. So I have a little picture of a candle here, and I just want you to think about that. If we take a candle, a brand new candle, and we light it, and we let it burn over time, what do you expect to happen to the height of this candle? Well, if you said you expect it to get lower and lower, or just shrink, or to get smaller, I would absolutely agree with you, right? It's gonna, the wax is gonna melt down and start puddling here, but the actual height of the candle then is gonna start shrinking. So we can already start predicting what type of relationship this is gonna be, and whether the slope or the rate of change is gonna be positive or negative. So with that, let's go ahead and look at the data. So here's the data. So this is taken from a candle, and every 15 minutes, so here it was at 0 minutes, it was 18 centimeters high, and then 15 minutes later we measured the height, and it was 17 centimeters, and this so just kept every 15 minutes measuring the height. So again, I kind of want you to get a picture in your mind. What would the graph look like? Is it going to be a positive slope, a negative slope? What do you see happening here? And then maybe sketch that out, and pause the video to do that, and resume to check back when you're ready to compare your work with mine. If you drew some sort of sketch that looks like this, showing that the height, and we could maybe even label this in here, at when we first get the candle, it's 18 centimeters high, and then we notice it goes 17, 16, 15. So we notice that it's decreasing as the minutes tick on here, right? So we're expecting a negative slope, and that makes sense for our experience of what happens to a candle when we let it light it and let it burn down. So what I'd like you to do here is to actually see if you can do like we did in that first example, put in the arrows and label what is the change in x and the change in y, so we can figure out how fast is this candle burning and determine that, which is determining the slope of this linear relationship. Alright, how'd you do? So what I noticed here in the table is that the change in y, the height, was decreasing by 1 centimeter each time, because it went 18, minus 1 is 17, minus 1 is 16, and continued on. And that the number of minutes was increasing at an increment of 15. So it started at 0 minutes and then added 15 minutes each time. So the height of this candle is decreasing 1 centimeter for every 15 minutes that it's burning. So we can plug that into our slope over here, and maybe you've already done that. And that shows us how fast this candle is melting down. And we, of course, the second part of the information we need is the y-intercept. How tall was it when we first got it, when it was brand new? Yeah, if you said 18, I would agree with you. So put that all together into our equation and let's check and see if we agree. So how'd you do? If you came up with the equation y equals negative 1/15 x plus 18, I would agree with you. And again, this equation is helpful because we could use it to predict how many minutes the candle would need to be burning before it completely melted away. Or we could plug in, since x represents any number of minutes, we could plug in, well, how long or how tall will it be? So we could plug in 120 minutes. After 120 minutes, how tall will it be? And plug that into my equation and figure that out, because when I do that, y would be the height of that candle. Alright, so that concludes our video. You can see the summary down here, so please take a moment to make sure that your notes are complete. Write a little summary about how to find the slope and the y-intercept in order to write an equation from a linear data table, and we'll continue to work with these different representations of linear relationships in class.